In 2022, the United Kingdom recorded 16,000 corporate fires. This volume of incidents occurred in one of the most strictly regulated commercial environments on Earth. The immediate result of these fires is severe. 40% of the affected businesses are forced into a temporary operational shutdown. The long-term consequence is often permanent. 65% of those shuttered businesses are outpaced by competitors and never reopen. When facility managers face these risks, the standard response is to increase the procurement budget. This leads to the purchase of higher resolution cameras, reinforced doors, and automated suppression systems. This is the hardware fallacy, the belief that buying individual components is the same thing as buying security. Surviving a corporate disaster is rarely determined by the price of the hardware. It depends on how those individual systems are integrated into a single strategy. Facility management is governed by two primary threat vectors: human intrusion and environmental fire. While an intruder and a short circuit behave differently, failures in both vectors are often linked to how a facility manages its safety protocols over time. In the realm of physical security, total failure inevitably occurs when facility management completely ignores the fundamental mathematics of time deficits. In fire safety, the risk increases when a facility unknowingly mixes incompatible regulatory philosophies. Both risks are exacerbated by the assumption that a facility's environmental hazards never change. We need to examine how the security time deficit and the fire code mismatch actually lead to operational collapse. True facility resilience requires moving away from the procurement of isolated hardware toward a unified architectural strategy. There is an uncomfortable truth in physical security: no fortress is impenetrable. Given enough time and the right tools, every system can be breached. This dual timeline graphic shows that physical security is an equation of time management. Active security consists of components like CCTV, intrusion alarms, and access control logs. Active security is reactive. It functions as a notification tool, alerting management that a breach is already in progress. There is an inherent delay following that notification. It takes minutes or even hours for security personnel or police to arrive on site. This is why passive security is necessary, utilizing reinforced concrete, grade 1 safes, and delayed entry locks. Passive security exists for one purpose: to stretch the time required for an attacker to complete their objective. If the attacker completes the physical breach before the response team arrives, the system has failed. Success occurs when the response timeline overtakes the breach timeline, neutralizing the threat. An expensive active alarm is useless if the facility lacks the passive barriers required to buy enough time for the response to matter. In fire safety, the hardware fallacy leads to a mismatch in regulatory codes. These are the two globally dominant fire safety philosophies: the American standard, NFPA, and the European standard, EN. The American NFPA approach focuses on aggressive active suppression, relying on sprinklers and water flow. The European EN approach prioritizes passive compartmentation and rapid smoke management. Failures often occur during routine facility maintenance or equipment upgrades. Imagine a facility designed to American NFPA standards that needs a replacement fire door. If a contractor installs an EN-certified door into this NFPA building, they are creating a technical failure. NFPA standards evaluate doors based on their ability to stop active flames. EN standards evaluate those same doors on their ability to contain both flames and toxic smoke. Mixing components from these two philosophies prevents the active and passive systems from working together as a cohesive unit. The hardware fallacy also assumes that an operational environment remains the same after the day of installation. We see the consequences of this assumption in the corporate server room. These rooms use clean agent gas suppression systems, like FM200 or Novec gas, because water would destroy the electronics. At installation, these systems are calibrated to the room's specific heat and fuel load. If the IT department later adds a rack of lithium-ion backup batteries, the room's fire profile changes. Lithium-ion fires involve chemical processes that legacy gas systems were never designed to suppress. This requires recommissioning, an engineering audit performed every time a new variable enters a protected space. Without recommissioning, the existing suppression system is obsolete against the new risks in the room. Hardware components are just individual tools, but the fully integrated architecture of those tools is your actual shield. Physical security requires synchronization between active notification and passive delay. You must engineer the physical delay to exceed the time it takes for a response team to arrive. Fire safety requires staying within a single, unified regulatory framework. Do not mix NFPA and EN compliance standards within the same facility. Safety is a continuous process, not a one-time installation. System recommissioning must be mandatory for any environmental or structural change. To prevent catastrophic downtime, facility management must shift from a hardware procurement mindset to an engineering mindset.